Welcome to the course Digital Storytelling. My name is Luka Piškorec. Topic today is, I called it AI Collage, Advanced Image Editing Techniques, so style transfer and image hybrids. And these are really topics that are on the fringe today, but somehow when you, they come up from time to time in, some art blogs, on some kind of high level, let's say, work, like say high level work from sort of digital artists, and also in the architectural practice, let's say, that these topics would kind of come up. And then I wanted to sort of wrap some of them up here and give you sources. So you can basically, if you're interested more, you can go and explore them on your own. But give you also a little bit of an outlook, kind of how the future will look like. Or so everything that we, if you think that Photoshop is, the future, that's already, that's already in a way in the past, or the future will look a bit different. And I'll try to give you a glimpse of that. Okay, so one big part of this lecture is AI generated images, or when we say AI, we mean artificial intelligence. So specifically machine learning models, deep neural networks, and their generative capabilities. Or so they are, their ability basically to generate imagery. And here in this first part, basically all the work is based on this model. It's called Pix2Pix. So you will find it under different names. Sometimes they are called GANs, so generative adversarial networks. Sometimes, and then connected to that, like a subset would be these conditional adversarial nets. But basically, these very often this specific kind of model is called Pix2Pix, so pixel to pixel, and it's based on this research paper published in 2017. So that's already 4 years ago, and you can go on their GitHub page, and they have kind of the research and also the some outlook of that work from other authors is compiled on their page here. So that's a great reference that you can then visit. But I'll just show you a little bit. What does that mean when we say artificially or AI generated imagery? Or so specifically, imagine that you, for example, have a sketch, or you're doing sketches, and you kind of sketch a shoe, and then you want to go from this sketch into a photograph. Or so it turns out that these generative adversarial networks, or specifically these Pix2Pix models, they are actually able to do that. They're trained on database of images, specifically here shoes, and they can sort of extrapolate, or they can kind of figure out how does the shoe based on this image need to look like. And here I'm only showing you without labels. One of these images is the actual photograph, so from the database, and from which these kind of lines are extracted. And the other one is computer generated, or so one of them would be called the ground truth, and the other one would be called the network output. Or so one of them is real, one of them is fake, and I will not tell you which one is which, but you can kind of maybe figure it out a little bit on your own. Or so one of these images doesn't, or one of these shoes doesn't really exist. Okay, another example, another type of shoe, and again, one of them is a real photograph. And the other one is computer generated. Or so basically, this model, this trained neural network, is able to create a pretty photorealistic looking image just based on these lines here. And again, it can do this because it was trained on images of many shoes, and it just kind of basically knows how shoes should look like. Unfortunately, it didn't include some other bit fringe examples. Of course, the question is, what happens when you are not inputting, and the sketch that you're inputting is not, doesn't look like a bag, but looks like something else, then you can get very weird results. And that's, I think, also where the sort of really creative potential of these models lies. Okay, this one is called Sketch to Handbags. Also on the bottom, there's always a link. So this is the link to the results of the model, so you can see many other examples. And if you go to their GitHub page, you will see the original paper and then many other links. You can kind of navigate your way around. Okay, so 2 handbags, 1 real, 1 artificial. Another example with handbags. You can kind of figure it out a little bit that, you know, one of them looks maybe a little bit, so the details are not really sharp. Maybe in this one here, the details not that sharp as here. So that might be kind of a clue, which one might be fake. Okay, and then it's the last bag example here, Montana West, something like this. Okay, then another use case is in a way applying sort of a very high level filter to the image. Or so we are all used to filters from, for example, Instagram, or in Photoshop, there are also filters that work sort of on a pixel basis. And then there are these high level filters that are again based on these generative adversarial networks, which are trained on data sets of images, and they can then do higher level manipulations. For example, here we can translate a daylight image, so day image, into a night image. So again, one of them is the actual photograph of a night image, and the other one is a network output. Or so in a way, you could just take a photograph and you could sort of change the time of the day. Another example is the daylight picture and again, one real, one output, a night image. And of course, I mean, these are currently still quite low resolution. Also depends a little bit when the models were done, but the kind of resolution of these networks is increasing all the time. I think this may be 512 by 512. So it's a bit limited, but this technology is advancing. So in 1 or 2 years, you will get kind of these networks will just be able to work with larger images. That's it. Okay. Again, daylight image and then sort of a night filter on it. Another use case, map to aerial photo. So we have just a screenshot from a city map. And then one of them is an actual aerial photo from Google, and the other one is a computer reconstruction. Or so basically, again, the network can kind of look at this image here and figure out, these are buildings, these are roads, this is something in between, and it's able to sort of fill in the details. Okay, another example, this one with a road. Here it's maybe a bit easier to see because there's something weird kind of happening here with the road. And then this is a kind of again sort of park example. Here it's a bit harder to see which one is maybe which one is real and which one is computer generated, because in nature everything is a little bit fuzzy anyways. Okay, another use case where you work sort of with diagrams, and in this case you can create, you can kind of say, well, this is a diagram of a facade, and different colors represent different parts of this facade. So maybe this is the blue is the wall, red is the roof, light blue are openings, so these are actually windows, and this other blue is the are doors, and then maybe this is some kind of balustrade and so on. So you basically create a diagram of your facade, and then one of them is the ground truth, so the actual photograph on basis of which this diagram was drawn, and the other one is network output. Here it's maybe a bit easy to see. Or so this one is the network output, and this one is the actual photograph. But it's quite eerie, or how kind of how realistic it gets. Okay, this example here, kind of a nice sort of a urban facade. I think this is in Zurich, and here something interesting happens. So this is actually a kind of a modernist style sort of high rise, and this is the example, and here we see the output, or this is the ground truth on the left, and on the right we see the output of the network. You see something weird happens, or it's basically a style transfer, because the network was trained on facades of old buildings, so old kind of urban cores, 19th century, 18th century buildings, maybe beginning of the 20th century, and then these ones are of course modernist buildings, so from the 1920s onwards. But somehow because the network doesn't really know, or doesn't really recognize the style, but it can kind of replicate it. It just replicates that what it sees. And in that sense, this diagram now became you know, we have the same geometry, but somehow the detailing looks like on an old building. So this is basically a style transfer, or the network was trained on a different style of buildings, so it kind of recreates that style, even though the number of floors and the number of windows is kind of trying to match there. So this is already an example of a style transfer. Also, these networks are able to somehow learn basically a style of a building, at least in this very narrow sense, kind of a sort of, you know, visual style. What does the style even mean? Or so kind of aesthetic properties of a style. Okay, another use example, diagram to street. So when you want, if you want to, when you're looking, for example, at the kind of field of machine vision and self-driving cars, what these cars need to do, or what these kind of machines that are trying to navigate through real world, what they have to do something called semantic segmentation. That means they have to look at the image and have to figure out basically which pixels are what are. So what is the road, what are the buildings, what are the other cars, the other pedestrians, and so on. So this semantic, I think it's, I apologize if I'm using the wrong term, but I think it's called semantic segmentation. So basically segment the pixels and determine which pixels are actually what are. And this is not based on the color. This is based on the on sort of figuring out what's in the image, you know, the three-dimensionality of the image. And then you can use that in a reverse also. I can kind of input the diagram of some cityscape or urbanscape, and I can kind of use the same sort of photographs then to train the network to basically reconstruct these cityscapes. Also, again, one of these images is a real photograph of a street, and the other one is just network output. Okay, again, kind of semantic segmentation, sort of a diagram of a scene, and then reconstruction. So again, these are, for example, cars, two ones are car, road, and then even some greenery in the back. And this is the last example. So the red are people. So there are some pedestrians going across the street, and yeah, one of them is a photograph, the other one is a reconstruction. Also, the network never really saw the original photograph, but it kind of knows what it should be there based on this diagram. Okay, and then not to go too much into that, there are of course many artists and architects, but also artists, graphic designers who are working with these tools. And again, this is not a really comprehensive presentation of their work, but maybe a few names. Mario Klingemann got quite popular at one moment. So this is a work from 2018 called Neurographer. So the idea is he basically, again, trained these same networks, and then played a little bit, you know, with what is the training data, but what is the actual input into the, so what is the network trying to reconstruct? Or so he would, for example, train the network of images of, it's a bit hard to see what is here, but maybe some, I think these are kind of electron microscope images, but somehow the input that the network is trying to reconstruct is a human face. Or so the network basically needs to use fragments of the images that it knows in order to reconstruct something that it sees for the first time. In that sense, in some narrow sense, the machine is here being creative. Or and yeah, Klingemann was using this as basically to create these sort of artworks. And in a way, they're also kind of high-level collages. Or so this is basically a collage between these kind of microscopic images, and yeah, to kind of create, in this case, a human face. Okay, another example, neural decay. Again, playing a little bit with kind of what the network is trained on and what is it trying to reconstruct. Of course, portraits are great to reconstruct because it's you know, we are using the inherent ability of humans to recognize patterns, and we're very good in recognizing facial patterns. So we can kind of sort of see faces even when there is no face really here. Okay, Jim Kogan does something similar, but basically tries to generate or trains the network on artworks. So yeah, art pieces from different authors, and then or different artists, and then tries to basically create like fake examples of them. So kind of basically try to in this example kind of generate pieces that look like work of Salvador Dali, or in this case Jackson Pollock. Or so this sort of this is just kind of what the network is able to sort of replicate. Okay, and this brings us then to this topic of style transfer. And here I'm just going to show you examples from, there's actually an app called PRISMA from PRISMA Labs. There are some other apps out there. This one I downloaded also for my phone back in the day. So, but I'm pretty sure app is kind of quite more advanced now. So you can, for example, then basically apply these high-level filters to your images. So this is, for example, an image from Tyrol, mountainscape, and then we have an example image, or the style that we want to copy is the Great Wave of Kanagawa from Hokusai. And then we are sort of applying the style of that painting onto the photograph that we have. Or this is the original photograph. This is the style that we want, and then kind of the network is trying to apply the style to the photograph. Now, again, this you cannot really yet do in Photoshop. So these are kind of very specialized tools, but they are available as commercial products, and I'm pretty sure very soon they will also be integrated in, Photoshop and all the other sort of graphic software. It's just that now currently there are some companies that have monopoly there. Okay, another example, the screen from Edward Munch, again already 100 and more years old, and then sort of application of that style onto the same photograph, or so somehow the lines, the colors, the contrast is matched. And then some other examples with without showing you the original paintings, but basically, again, same photograph, different expressions. Now, if you would want to do something like this in Photoshop, it's kind of clear that it would take quite some time to actually do it. Or so you would really need to go into digital illustration and really start to kind of, paint basically. But here, these filters are, they work very, very fast, because one feature of these neural networks is that they're very hard to train. It takes a very long time to train them, and once when they're trained, their application is very fast. Or that's why pattern recognition, if you have a network that is already trained to recognize patterns, it works really fast. So it can recognize, for example, faces in a photograph in real time, as you're kind of pointing it with your camera around. Okay, so they're very fast to apply once when they're trained properly. Okay, different styles of the same image. Okay, and again, this was already like 5 years ago, so I'm pretty sure the app has advanced already. So pretty sure you can do maybe even some more cool stuff there. Okay, and then this is the kind of last part, AI generated hybrids. So in a way, you can use this principle of letting the kind of some neural network to generate your images. You can then use this to also create, I mean, here I call them hybrids, but they're basically, again, some type of collages. And our work here is based on so-called big GAN network, or again, GAN stands for Generative Adversarial Network, and it's trained on the ImageNet, which is a very large database of images online. So, yeah, this is the original paper, again, what is this, 3 years ago, and they have implementation. So if you know a little bit of Python, you can run their implementation in PyTorch, but this is actually from in Google Colab, which is like a online, you can run it in the cloud, their code as well. I think this is implemented in TensorFlow, and that's actually how these next images are created. So it's not really user-friendly yet, but again, if you know a little bit of coding, it can get you sort of far. And yeah, that's why there are also not a lot of artists that use these techniques, because there's just the learning curve is quite steep, or so they're just not integrated yet seamlessly in sort of a user-friendly software. So you have to just run the code yourself. Okay, so this was the work then that I did with a studio that I have with colleagues from Zurich and Belgrade. And this was again last year. We're playing a little bit with creating these hybrids. So we would kind of choose 2 categories and then try to sort of find kind of hybrids between them. Basically, how the network does it gives you, or you can let it map sort of a grid of hybrids, where sort of on the left you have one category, in this case a drilling platform, on the right you have another category, in this case a cash machine. And sort of in this middle column, you basically get the hybrids, or they're kind of more or less successful. This may be one selection of them. This is another one, the hybrid between a monastery and a bolotai. So again, this is how you can set the network to give you the output. So again, in order to be able to choose a little bit better. So on the left, you have, again, completely AI generated images of a monastery. On the right, a bolotai, and in between you have sort of a hybrid between these. This is a hybrid between the valley and the solar dish. So you can see a little bit something weird. It's kind of a shiny mountain, shiny valley. It's kind of a cloud here. And yeah, so many of these networks are today, they work really well on human faces. So to generate sort of faces, because of course that's also where maybe the commercial applications lie. But here we focus mostly on these kind of landscapes, cityscapes, and sort of artificial objects, and try to kind of find these hybrids in between. This one is also quite interesting, the scale and the space shuttle. You can see sort of a house is sort of hanging on this, it's like a hanging scale. Okay, on the left, scale, on the right, space shuttle, and in between the hybrids. Okay, and I think this may be the last example. Electric fan and radio telescope. It's also quite funny that it's sort of green, but here it is, because radio telescopes are usually integrated in some landscape. They're sort of singular objects in the kind of usually empty landscape. They have to be far away from cities, electrical grids, and so on. And that's why there's kind of a lot of greenery on these images. And then the electric fan has this sort of circular pattern. And then when that gets merged, you get sort of something maybe in between. Okay, and it's important to know that this is a continuum of solutions. Or so this grid, you can actually subdivide it as much as you want. You would basically get, you can sort of interpolate as much as you want. And now also in the group, we are working on making these into animation sort of GIFs. That's sort of very easy to do, but it takes a bit of time. But now we are kind of doing the selection, and then we're going to do some animation. So it's actually possible to do animations from these. So you have kind of continuum of solutions, and maybe online you already saw some examples where people use these guns to create sort of animated hybrids, let's say. Okay, so the point of these, what I showed you now, is a little bit to show you a bit view into the future. So how the future might look like or will look like. And you can now, think for yourself as you're maybe at the beginning of your studies, or maybe in the middle, who knows, but most of you are maybe in the beginning, you can kind of think, okay, so I'm leaving, maybe I'm finishing my studies in 5 years or something. Maybe you're already going to work in offices and so on, and you should really think about how these tools influence what we do, or how do they influence kind of our creative work. And I hope you will not take the position of thinking that somehow these tools will sort of replace us, or so kind of this. It just gives us a lot more freedom, or in how we can do things. We can actually expand our own creativity. And yeah, this whole kind of a discussion of can machines be creative, it also depends on how you define creativity. So what was that, 30 years ago, we defined intelligence wrong. He said computers cannot play chess because chess requires, creative intelligence, and computers cannot do this. Comes Deep Blue, beats Kasparov. Okay, computer can now beat the world grandmaster in chess, but that's not real intelligence. Or Go is a real intelligence. If you play a game of Go, that's the proper intelligence. That's like real intuition and creativity. AlphaGo comes, beats the world master in Go. So we are kind of pushing the boundary of what it means to be intelligent. Also means that we didn't really define well what intelligence means. And I think you have a similar story with creativity. We are constantly saying machines cannot be intelligent, or machines cannot be creative, because creative is somehow reserved for us, for our own kind of exceptionalism and brilliance. But then we are, these tools kind of prove that under some narrow definitions of creativity, machines can be creative. Or It doesn't mean that they will replace us, you know. So there's some of these topics are, I think, very very contemporary, and I would like you to take a contemporary stand on this. You know, you should really kind of you should not lock yourself in your discipline, but really kind of think critically about these, you know, tools. What do they mean, you know, and what does it mean when a creative individual or architect or designer becomes just a user of tools? Like, you can argue that using Photoshop, you're just a user, you know, rather than a creative individual, you know, because somehow Photoshop does everything for you, or doesn't. Cool. Thank you very much. And see you.